What's up everybody? In this video, we are going to learn how to combine the distance sensor with the motors to create a collision avoidance system for a robot. We will combine two previous sketches, the ultrasonic distance sensor and the motor driver dash functions. Start off by logging into Tinkercad using your course username. Select circuits in the menu under your designs. You will see our ultrasonic distance sensor sketch. Hover over the circuit and right-click Tinker This. Open this sketch in a new tab. Next, hover over the motor driver dash functions circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to motor driver dash collision detection. Search the components using the keyword distance and select the ultrasonic distance sensor under the other components and add it to the artboard. Connect the VCC pin to power on your breadboard using a red wire. Connect the GND pin to ground on your breadboard using a black wire. Connect the trigger pin to pin 12 on the Arduino and echo to pin 13 on the Arduino. Let's jump over to the ultrasonic distance sensor sketch. We're going to copy the code from this sketch and put it into our motor driver collision detection sketch. First, select the three variables we created and copy them. Paste them below the motor variables in the motor driver collision detection sketch. We need to update the pins in the variables. Change trigger pin to 12 and echo pin to 13. If you recall, we created a function called getDistance that we can use to return a distance value. Copy the function from the ultrasonic distance sensor sketch and paste it below the variables for our ultrasonic sensor. Great! Now we can use this function and combine it with our motor functions. Let's update the loop function. First, delete the motor functions from the loop. The input from our distance sensor is going to be what we are going to use to determine if our robot is going to collide with something. So at the start of our loop, we update the distance variable. Type distance equals getDistance, open bracket, trigger pin, comma, echo pin, close bracket, semicolon. Below, write serial.println, open bracket, distance, close bracket, semicolon. Click Start Simulation and open the serial monitor. You should see the value of the distance showing up. Compare the values in the serial monitor to the values when you move the ball to test the distance. They should be the same. Great! We are measuring the distance that the ultrasonic sensor sees. Now that we have the distance reading, we can use a conditional statement to create some intelligence for our robot. Type if, open bracket, distance is less than or equal to 10, close bracket, open curly brace, close curly brace, else, open curly brace, close curly brace. We are checking to see if distance is less than or equal to 10. Remember, our distance value is in centimeters, so a value of 10 or less would mean we are about to collide with something. Inside the curly braces, after the if, write stop, open bracket, 25, close bracket, semicolon. In the curly braces after the else, add forward, open bracket, 255, 255, 25, close bracket, semicolon. This means that our wheels will move forward until the distance sensor detects a value of 10 or below. When this happens, the robot will stop. Click Start Simulation and test this out. Click the distance sensor and move the little ball. When the value drops below 10 centimeters, the motors stop. They remain stopped until the distance sensor detects a value higher than 10. Move the ball out and you will see the motors move again. Our circuit is very responsive, but why is this? You will notice that I have used a very short delay of 25 milliseconds when I call the stop and forward function. When we call the forward and stop functions, we pass a parameter called how long. This determines how long the Arduino will call the delay function. Remember, when the Arduino calls the delay function, it stops making calculations and runs its previous code until the end of the delay. If we have motors moving forward and a long delay, It will impact when the program loop completes and reads our distance sensor. Let's test this out. Change the how long parameter in both the stop and forward function to 2000 milliseconds or 2 seconds. Also, uncomment our serial.println statements at the start and end of the program loop. Click Start Simulation and move the ball to simulate that we are going to crash into something. You will notice that it takes a long time for our motors to respond. This is because of the delay function blocking the execution of our code. You can also see this in the serial monitor as it prints when it gets to the end and the start of the program loop. Change the how long parameter back to 25 milliseconds and comment out the serial.println statements. So stopping the motors is okay, but if we want to make an exploratory autonomous robot, we will need to program a different behavior. Highlight the stop function inside the if and change it to avoid collision, open bracket, close bracket, semicolon. Below the loop function, add void, avoid collision, open bracket, close bracket, open curly brace, close curly brace. Let's create a behavior when the robot is about to collide. Inside the curly braces type backward, open bracket, 255, 255, 500, close bracket, semicolon, then left, open bracket, 255, 255, 500, close bracket, semicolon. Click Start Simulation. Now, when the distance value is 10 or below, the wheels will reverse and turn left. Provided the distance value is above 10, the wheels will move forward again. As you test this code, and when you build the circuit, try some different behaviors in the avoid collision function. You can also use different sensors and create new behaviors to respond. At the end of this video, you should have a better understanding of how to combine the input of a distance sensor to control the motor functions of your robot.